construction of AC generator. First of all, you see the diagram. It is very simple diagram, okay, and it consists of 6 essentials. They are field magnet, armature, slip rings, brushes, load and source of energy. See, field magnets. First one is field magnet. It is a permanent magnet of the horseshoe shape in a small dynamo, magneto, or it is a powerful electromagnet in a large dynamo. It produces a strong magnetic field in the region between its pole pieces. Second one is armature. PQRS. PQRS is called as armature. It consists of armature. It consists of a rectangular coil PQRS having a large number of turns of insulated copper wire wound on a soft iron cylindrical core. The core is laminated on Number 3, slip rings. S1 and S2 are two slip rings. The two ends of the armature coil are connected to two coaxial brass rings S1 and S2 called slip rings. S1 and S2 are called slip rings. The rings are rigidly fixed to some shaft which is used to rotate the coil. The slips are insulated from each other as well as from the shaft. As the armature coil rotates, the slip rings also rotate about the same axis of rotation. Now, number 4 is brushes. See, B1 and B2, they are brushes. Two graphite or flexible metallic rods called brushes are lightly pressed against the two slip rings. The brushes B1 and B2 remain fixed in their positions and maintain sliding contacts with the rotable slip rings S1 and S2. It is through these brushes that the current induced in the armature coil is fed to the external circuit by means of line wires. Then fifth one is load. Here you see it is load R. Okay, we can connect any bulb or any device. So fifth very important thing is load. Now sixth is source of energy. The armature coil, this rectangular coil PQRS, the armature coil is rotated about its axis. You see motion, okay, here and here you see arrow mark shows motion, okay. Now the armature coil is rotated about its axis with the help of turbine or any other device connected to it. It is the rotational kinetic energy. It is the rotational kinetic energy of the turbine which is ultimately converted into electrical energy by the AC generator. Students, today we are going to study AC generator. A generator or dynamo is a device which converts mechanical energy into electrical energy. It does not generate any energy. It only converts mechanical energy into electrical energy. See, an AC generator is the one which produces a current that alternates or changes its direction regularly after a fixed interval of time. That is, it is a device which converts mechanical energy into electrical energy. The present form of AC generator is due to Nikola Tesla, who built it in the year 1888. Principle: the working of AC generator is based on the principle of electromagnetic induction. When a closed coil is rotated in a uniform magnetic field with its axis perpendicular to the magnetic field, the magnetic flux linked with the coil changes and an induced EMF, and hence a current is set up in it. The core is laminated one to avoid losses due to eddy currents. The soft iron core concentrates the lines of force to increase the flux density B, capital B. The armature can be rotated in the magnetic field of the field magnet about an axis perpendicular to field B. Then the magnetic flux linked with the coil at any instant t will be phi is equal to NBA cos theta, or we can write NBA cos omega t, that is phi is equal to NBA cos omega t. By Faraday's Flux rule, the induced EMF E is equal to minus of differentiation of phi with respect to time. Mathematically, we can write E is equal to minus of ddt of phi. Substituting the value of phi, we get minus of ddt of NBA cos omega t. After differentiation, we get, after differentiation, here you see NBA, they are constant quantity. So after differentiation of this cos omega t, we get E is equal to NBA omega sin omega t. Or we can write E is equal to E naught sin omega t, where E naught is equal to NBA omega. For this particular NBA omega, we are using E naught. When a load of resistance R, this load, when a load of resistance R is connected across the terminals, a current I flows in the external circuit. Okay, now from Ohm's law, we know V is equal to IR or E is equal to IR. So we can write I is equal to E upon R. Substituting the value of E, we can write I is equal to E naught sin omega t upon R. Or we can write I is equal to E naught sin omega t, where I naught is equal to E naught upon R for this quantity. E naught upon R, we have written I naught. That's why I is equal to I naught sine omega t. Both current and voltage vary sinusoidally with time. The power dissipated on the load is supplied by the agent in rotating the coil in the magnetic field. By the agent in rotating the coil, this coil, rectangular coil, in the magnetic field. Now, expression for induced EMF. Let N be the number of turns in the coil. Here we are having one rectangular coil PQRS. So let N be the number of turns in the coil. A be the phase area of each turn. B magnitude of magnetic field theta, angle which normal to the coil makes with field B at time t. Omega, angular velocity with which coil rotates.